Hello everyone. So in this video lecture we are going to learn about depth first search DFS, that is another graph traversing algorithm. In previous video we have learned breadth first search, that is BFS algorithm for the traversal of graph. Here we have depth first search. So ultimately depth first search is the goal is same for the traversal we use, but the method is different. In BFS, we go level by level. We visit the vertices in each level. Whereas here, we are going deeper and deeper until the goal node is achieved, right? So it's like we start from one end and then we go deeper and deeper and deeper following that particular path, right? And when a dead end is reached, the algorithm backtracks, right? So it returns to the most recent node that has not been completely explored. If you have explored one path of that particular node but the second part is still remaining, then we backtrack up to that particular node and then we'll explore the other node. So that is the process that we follow in depth first search. I'll explain you with an example. So let me take one graph over here. See, in BFS, we learn that algorithm. So you are aware of what is BFS. So in BFS, we used to follow the level, right? And for that, we use queue. We use queue structure for implementing BFS. So here in DFS, we are going to follow the stack. So this thing you need to keep in mind. You might be asked that what is the difference between DFS and BFS. So you can tell that DFS explore the nodes by following the path, so it goes deeper, while BFS you go level wise. In DFS you follow stack, while in BFS you follow queue to implement it, right? In that also I told you that you need to start from one vertex, right? That would be your starting vertex. In examination, if it is given, then you can simply start with that vertex. If not, then you can choose by yourself and you just need to mention that start vertex, that what would be your start vertex. That would be easy, right? So usually we can start by A itself. It's not a rule that we need to start with A. We can start with A, we can start with B, C, anything, right? But here you need to mention that what you are going to start. Let us say, for example, here we are going to start with H, right? So my starting vertex is H, right? So whatever DFS sequence I'm going to have, that would be from the starting vertex H, right? If you do it by yourself and if you choose any another vertex, right, then that DFS sequence will differ, right? So in an examination, just make sure read the question twice, that what is written there, what starting vertex is given, right? If it is given properly, then not an issue, right? You need to just follow it, and if not, then you just simply mention here that this is my starting vertex, right? Okay, so now what you need to do, as I told you, that we are going to follow a stack. So I'm just roughly drawing it over here, that this is my stack, and I'll just have indexing over here. Okay, and this is my visited, where I'm going to whatever node I'll visit, whatever vertex I'll visit, right? I'll just write it over here, right? Okay, so what you need to do, the first step is whatever is your starting vertex, you need to just push that starting vertex onto the stack, right? So here I'm having my starting vertex H, so I'll just push H over here. Now next what you need to do is you need to pop that top element, right? As of now I'm having only this top, right? So this is my first step, that I need to push the starting vertex to my stack, right? Next, whatever I'm going to do, those steps are going to be repeated until you don't have that all the vertices will be visited, right? Until that you need to follow it, right? Okay, so what are those steps that we need to follow? That you need to pop the topmost element from the stack, right? And after popping it out, the whatever element you have been popped, that would be considered as the visited, right? And you need to push its adjacent nodes, right? Adjacent vertices to the stack, right? So for that, let us have adjacency list, because if I have a adjacency list, then it would be easy for me. So for A, we have like A to, I can go to B, C and D. This is my directed graph, so you need to be very clear with the directions, that arrow is on the which side. From B we have only E. You might have seen that there is an edge from A to B and C to B, right? But that are coming towards B, not going outside. It's an in degree, not an out degree, right? So we need to only consider those out degree edges, right? So for B it's only E. For C we have B and G, right? For D we have C and G. For E we have C and F. For F we have C and H. Okay. For G we have F and I. Also we have from G I have F and I. Okay. Then from H I have E and I. Okay. And from I have only one, that's F, right? Okay. Now what I need to do, I'll just, my starting vertex is H, so I'll just pop this H out and make it as a visited. Once I mark it as a visited, what I need to do, I need to find the adjacent. So for H I am having adjacent E and F, right? So I just need to push that E and I, not F, E and I to the stack, right? So now my top will move to this, because I have pushed two elements, right? Okay. Now after this, again I need to repeat this step, right? So I need to pop the topmost element here. The topmost element is I. So I'm just popping out I and mark it as visited, right? And the adjacent node of I, that is F. So I just need to push F to the my stack, right? The stop is again, once I pop it out, it will be decremented and reach to 0. Then again I'm pushing a one element, so it will incremented and now it is to 1, right? Okay. Now next what I need to do, I need to pop the topmost element. So here the topmost element is F, right? And I'll mark it as visited, right? So once I'll mark it as a visited, this top would be decremented, right? It will reach to 0. Now I need to find the adjacent to F. So adjacents to F, I have C and H, right? So simply I need to push C and H over here. So now my top will be incremented by 2 numbers and it will point to the 2, right? So what path I'm following, I'm just marking that path as well. From H I went to I. From I went to F, right? Now from F, now what is the topmost element? So this topmost element is H, right? But you, while pushing to that particular stack again, you need to check that whether that element is already visited or not. Here this H is already visited, right? Here H is already available, so there is no need to push H, only you need to push a single element, that is C, right? Here you have C and H, and as soon as you discover that H is already available in my visited list, you just cross it out. So you have only one element, that's a C. So you need to push that C only. Getting this? Okay. So now next what you need to do, you need to pop out the element. So topmost element is C. I'll just pop it out and mark it as a visited, right? So my top would be decremented to 0, right? So here I'm going from F, I'm going towards C, right? Okay. Now what I need to do, I need to go for the adjacent of C. So the adjacent of C is B and G. Again you check, B, is it available in visited? No. Is it G is available in visited? No. So what you need to do, you need to push both of this element to the stack. So I'll push G over here. So my top will be incremented to 1. Again I'll push G over here. So now my top will be incremented to 2. Right. Now what I need to do is, I need to pop this G, right? So I'm popping out this G and mark it as visited, right? Once I mark it as a visited, what I need to do, I'll just mark it over here as well, that I went from C to G, right? Okay, so my top will be decremented and it is available over here, right? Now what I need to do is the adjacent of G, that is F and I. Now you need to check that F, that is already visited over here, so you just need to cross it out, right? I, that is also visited over here, you need to cross it out. So there is nothing to push, right? So no need to push anything, right? So you simply backtrack. This is what I said, that if there is no unexplored node available, so you just backtrack to the previous one. So here I have a B, right? So you need to pop B. Once I pop B, I need to mark it as a visited, right? So we have reached, like we started from H, we went to this I, then F, then C, then G. Then after this G, there is no way ahead, because if I go to F, right, that is already visited. If I go to G, that is already visited. So what I am doing, I am backtracking. I again go from G to C, and from C I am visiting this B, right? So I am reaching this B, right? Then what I need to do is that after that I need to find the adjacent of B. The adjacent of B is E. You need to check, is it available in visited? No, it's not available. So you just need to push that E, whether it is available into the stack, already available onto the stack, right? Then also you need to push it, right? Because sometimes it happens that it is like after in between that two there will be multiple nodes, right? So here it's a back to back E, but it might be possible that in between that you have few nodes as well, right? So now pushing this E, what you need to do is, again you need to pop the topmost element. So I have only one element, that's my E, so I'll just pop it out, right? And I'll mark it as a visited. Here also I mark it as visited, right? So now what you need to do is, you are doing with this, then from this B, E is already visited. Now you need to find the adjacent of E. So adjacent of E, if you go for, so that's a C and F. C is also visited, F is also visited, right? So you just need to backtrack. If you backtrack again, it's a E, so your stack is empty. Now you might think that here your stack is empty. So now next what to do, right? There are the vertices such as A and D, they are yet not visited, right? But DFS always goes for a path, right, that is reachable from that starting vertex, right? So here your starting vertex is H. So from H, the reachable vertices are only this much, right? So for H, you can have your DFS sequence that H, if you go for that, so that's H, I, F, C, G, B and E. Do not worry about A and D, right? If someone says that what would be the DFS tree, right? So the DFS tree would be, from H you are going towards I, from I you are going towards F, from F you are going towards C, from C you are going towards G. Again now you backtrack, from C you are going towards B, and from B you are going towards E, right? So this is your DFS tree, right? Now this happened because we chose the starting vertex H, right? In the same, if we choose the starting vertex some another, right, let us say A, then what will happen, right? So I'll show you that as well, right? So let me just have just a moment. So we have this graph here. I'll write it, the index is 0, 1, 2, 3, right? So now we are starting from vertex A. Same example, but I just need to show you that from A, if we start, then what happens, right? So we simply need to push A, right? And then we should have one visited where we'll mark that. So I'll pop it out A and mark it as a visited. So here I have this A. Along with A, I need to find the adjacent of that. So that's a B, C and D. So I'll just need to push B, C and D, right? So my top will point out over here, right? So now what I need to do, I need to push the topmost element, that's my D, right? So I'll pop it out, sorry, not push, I need to pop, right? So I'll pop this D and mark it as a visited. So I started with A and I'll go towards D, right? Once it is done, I need to search for the adjacent of D, that's a C and G. You need to check whether it is already available or not. So C is not there, G is not there, so simply you need to just push a C and a G. So now your top will point to this, right? Now what you need to do, you need to pop the topmost element. So topmost element is G, right? So I'm popping it out and mark it as a visited, right? So I'll just mark it from D, I'm going towards G, right? So now G is done. I need to go for the adjacent node. So adjacent node is F and I, both are not available in visited. So I'll simply push F and I. So now my top will point to this 4, right? Again, what I need to do, I need to just pop the topmost elements. The topmost element is I just need to mark it as a visited. So it is visited. I'll just make a mark over here as well. So after I need to go for it, the adjacent of I, that's F. F is yet not visited, so I'll just push it to the stack, right? So I have that F. I just need to pop out the F, right? Once I pop out the F, right, I need to mark it as a visited, right? So I need to go from here to this, right? Okay, now I need to go for the adjacent of F, right? So adjacent of F is C and H. You need to just check whether these are available or not in this visited list, right? So both are not available, so I'll just go from F. We have this line, this, yeah, right? So from F it's a C and H, right? So I'll just push C and H. So my this would be, top would be pointing over there in H, right? I need to just pop the topmost elements. The topmost element is H, right? I'll just pop it out, right? And again I need to mark it over here. So I'll mark here that I'm going towards H, right? After that, again I need to search for the adjacent. So for H, I have not mentioned here. So for H we have I, and from H we have I and E, right? So I and E, right? So if you go for I is already visited, it is available here, so no need to have. Then we have E, so simply we need to push that E over here, right? Now what I need to do, again I need to do the same thing, right? Pop the topmost element is E, mark it as a visited. Once I marked it as a visited, then what I need to do here, I'll just mark it that here, from here I'm going here, right? Once this is the done, right, then you need to find the adjacent of E. So adjacent of E, that is a C and F, right? So you need to check whether that C is available there. No, so you just push that C over here. F is available, yes, F is available, so just keep it out, right? So now what you need to do, again you need to pop the topmost element and mark it as a visited. So here I have visited C. I just mark it over here also. So I have visited this C. Then what you need to do is, you need to find the adjacent of C, that's a B and G, right? You need to check B, is it available there in visited list? No. So you need to pop this B, push this B over there in a stack, right? And G, it is already available, so just cross it out, right? So we have that B. Now the topmost element is B, so again you need to pop it out, that B, and mark it as a visited. So from C you are going towards B, right? And from B, again you need to go that adjacent of B. So adjacent of B is E, that is already available in my visited list, so no need to push anything, right? Now you go backtrack, you check C. C is already available into the visited list. Simply pop it out, no need to mark it as a visited because it's already visited. Then F, simply pop it out. Then C, that is also available, pop it out. Again the C, just pop it out, and B, pop it out, right? So these is the things you are having over here, right? So simply if you start from the vertex A, you will have this sequence, and if you go for the DFS tree, so that would be from A you are going towards D, from D you are going towards G, from G you are going towards I, from I you are going towards F, from F you are going towards H, from H you are going towards E, from E to C, from C to B. So this is your DFS tree. So I hope you understood it. Thank you for watching this video.